I'm going to be doing problem number 4 of Unit 8 in E&M. So problem 4 says, a loop of mass M and having a total resistance R falls vertically through a uniform magnetic field B as shown here. So part A, what is the direction of the induced current in the loop? So if we use our right-hand rule, we'll see that it actually moves clockwise. So if you use your fingers as the B field, which is into the page, and your thumb is the velocity, is the direction of the velocity, which is going this way, your hand pushes, the palm of your hand pushes this way, so the current is being pushed to the right, at the top, to the right. So that means that it will move around in this direction, which is clockwise. Okay, part B says, as it emerges from the B field, the loop reaches a constant terminal velocity. Show that the magnitude of this terminal velocity is given by V equals mgr over b squared a squared, where r is the resistance and m is the mass. So, if it's moving at constant velocity, we know that the sum of the force is going to be 0. So if we draw our little force diagram here, mg is the force downward from the weight, and the resistance is the force upward. So that's going to give it a terminal velocity because it has resistance. And the force of the resistance is just the same thing as the force of induced by the magnetic field. So that's going to give you current times L times B. And in this case, L is A in the picture. So our sum of the forces are going to equal mg minus I LB, which is this force, which equals 0. So shifting those around, you get I equals mg over AB, where L is A. Scoot this up. We also know that I is equal to the electric field over the resistance. So that gives you BL times the terminal velocity over the resistance. So setting those two equations equal to each other, we get BA times the terminal velocity over the resistance equals mg over AB. And shifting those around, we get that the terminal velocity is mgr over AB squared. Okay, part C. Show that while the loop is traveling at a terminal velocity, the rate at which heat is being dissipated in the loop is P equals mg over BA squared times R. So this is just asking us to find the power. So our equation for power is I squared R. And our I we just found in the previous problem here. So we're just going to plug that in. And you get P equals mg over AB squared times R.